Hello everyone, welcome to lesson 3-1, constant rate of change. In this chapter, we're going to address the question, why are graphs helpful? And the vocabulary we're going to look at are linear relationship and constant rate of change. Let's start by looking at a real-world example. Music. Marcus can download 2 songs from the internet each minute. This is shown in the table below. So in the time will be represented by the domain, and the number of songs will be represented by the range. Our domain, which is our horizontal axis, is x, and our range is represented by the y-axis, which is vertical. We have time, 0 minutes, 0 songs. 1 minute, 2 songs. 2 minutes, 4 songs. 3 minutes, 6 songs. 4 minutes, 8 songs. You can see that for every minute, 2 songs are added. This is a constant change. Compare the change in the number of songs, y, to the change in the time, x. What is the rate of change? Well, we notice that the number of songs increases by 2, and the time increases by 1. So the rate is 2 songs per minute. Every time we have 1 minute, we have an additional 2 songs, as you can see here. 1 minute, 2 songs. 2 minutes, 4 songs. Every time there's 1, it increases by 1 on the top, it will increase by 2 on the bottom, by number of songs. Question 2. Graph the ordered pairs from the table on the graph shown. Label the axis. Then describe the pattern shown on the graph. So we have to label the axis, okay? Well, technically, the first thing you ever want to do when you make a graph is you want to write a title, okay? The title will tell you what information you're looking at. Since we're talking about downloading music and the time it takes to download the music, my title will be Rate of Songs Downloaded. Whenever you are measuring changes in time, or how times can change, you always want to make sure that you put your time on the horizontal line, or the x-axis, which we call our domain. So this will be our time in minutes. Minutes is our unit. So if this is the time, this will have to be the number of songs. I couldn't put it vertically. The program won't let me turn it around, so I wrote it horizontally. But this right here is the number of songs. Okay, let's look at the table again. Here's our table, and I'll put it to the side where we can still see it, but it's not in the way. Okay, let's start plotting our dots. I will choose red because it's easy to see, and a large dot. And so we have 0, 0, and then we have, in the first minute, we have 2 songs. So we go horizontally first, and then, so we go like this. In the first minute, we have 2 songs. And then in the second minute, we will have 4 songs. There it is. In the third minute, we have 6 songs. Oops, a little too high. 6 songs. Still too high. That's the best I can do. And in the fourth minute, we have 8 songs. There we go. And that's how our rate of change looks. Now, something I want you to keep in mind is it's a straight line, and it looks like it's a straight line that if I were to keep going, it's going to go straight through 0, 0, because we run 1 and we rise 2. Run 1, rise 2. Run 1, rise 2. Run 1, rise 2. So you can see that it's a proportional, and it's a constant rate of change, and it will go through 0, 0, so it is a proportional constant rate of change. And if I draw my line should go straight through. There should be a straight line that goes through 0, 0. So what is a linear relationship? Let's take a look at what a linear relationship is. Relationships that have straight line graphs, like one on the previous page, are called linear relationships. Notice that as the number of songs increases by 2, the time in minutes increases by 1. And this is a constant rate of change. As we have +2 on the top, we have +1 on the bottom, and it doesn't change. It's not like here's +2, and then over here +2, and then here +5, and then here +7. No, it's constant. So the rate of change is 2 for 1, which is 2 songs per minute. And that's when we use the words constant rate of change. So the rate of change between any 2 points in a linear relationship is the same or constant. A linear relationship has a constant rate of change. Let's look at example 1. Here we have the balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning of why it's not linear. So let's see, number of transactions. They buy 3 things and we got $170. Okay. Another 6 transactions, $140. 9 transactions, $110, and 12 transactions. So this is like saying when we say 3 transactions, it's your ATM cards being swiped 3 times. And you have a balance of 170. Okay? Then another 3 times and you have a balance of 140. Every time you swipe your card, it looks like, or every 3 times it goes down by 30. So you could say that the constant rate of change is, for every 1, it's 10 on this side. Do you see it? Because if it's every 3, it's 30 here. Every 3, it's a minus 30, and another 3 is minus 30 here. Then we're saying, since the rate of change is constant, this is a linear relationship. The constant rate of change is $30 less, or negative 30, for every 3 swipes, every 3 use of the credit card or the debit card. Or we could say minus $10 per transaction. This means that each transaction involves a $10 withdrawal or expense, right? Okay, if you think you got it, go ahead and using this information as data, make a T-chart on your paper and record these data. These will be your study notes later on, and make a quick graph by simply making a Y and an X axis and adding in these increments. Now, notice something here that I want to draw your attention to. Let's look at the graph a little closer. This is squiggly line. The squiggly line that we have here is when we want to crush a certain number of information. If you notice, we're increasing by 20, correct? So that means each square is 10. 10, so it goes 50, 60, 70, 80, right? So every 2 is 20, but from here to here is 40. That just means that we have no data from 1 to 30. So we simply just make a little squiggly line and then we start counting at 40. Otherwise it would just be empty space here. Okay? So what is it that we want to do here? For these 2 pieces of displaying, or these 2 displays of information, I want you to tell me if you see a constant rate of change. So we have a table and we have a graph. So for this table, do we have a constant rate of change? If so, why? And tell me what the constant rate of change is. And if not, tell me why not. And here for B, we do the same. Is it a constant rate of change? If so, what is the constant rate of change? And if not, why not? Okay, go ahead, pause the video and try these on your own. Pause now. Okay, I hope you paused the video. For A, we're looking at cooling water. Time, for 5 minutes in the fridge, or it could be outside, at 95 Fahrenheit. Okay, after 5 minutes, the temperature of the water is 95. After 10 minutes, it's 90. So it went down by 5 minutes here were added, and it went down by 5 Fahrenheit. Another 5 minutes are added, but this time it only went down by 4. And then another 5 minutes are added, and this time it only went down by 4 again. So it went down by 5, but then by 4 and by 4. This is not constant. The time is constant, but the change in temperature is not. Well, so is the relationship linear? No. The rate of change from 5 to 10 minutes is minus 1 Fahrenheit per minute. You can see it went down here 5 minutes, it dropped down by 5. So it's 1 per minute, right? But the change from 10 minutes to 15 minutes is Negative 0.8 Fahrenheit per minute. You notice here we only dropped by 4. If you divide 4 by 5, you get 0.8. This is 4/5, right? And this is 4/5 right here per minute. So the relationship is not linear. B, we're looking at numbers of volunteers and the time. Okay, we had 8 volunteers, 80 minutes. 16 volunteers, 60 minutes. 24 volunteers, 40 minutes. So this is the higher the number of volunteers that we have, the shorter amount of time it takes to do the task. Is it linear? Well, let's see. Over here we're dropping by 20, and we double the number of volunteers. Drop by 20 and increase it again by 8. So here we're increasing by 8 each time, and here we're dropping by 20 each time, 20 minutes. So for every 8 volunteers, we save 20 minutes. You see? So is it linear? Yes. The rate of change is minus 2.5 minutes per volunteer. I did the math where I wrote out that we have 20 minutes divided by 8. Okay? That is the, here's my x and here's my y. And then when I actually solve for 20 divided by 8, I simplify this, I get 2.5 per minute. Now I put negative 2.5 because we're dropping. You see this? We have a slope going down to the right. So we're dropping. So it's minus 2.5 minutes every time we gain a new volunteer. Okay, now let's take a look at the key concept for the lesson. Proportional linear relationships. Words. Two quantities, A and B, have a proportional linear relationship if they have a constant ratio and a constant rate of change. Symbols. A and B is constant change. Change in B and change in A is constant, meaning the way this is changing and the way this is changing are both constant. So then we have a constant rate of change, which will be a linear relationship. It'll give us a straight line. Okay, let's see. To determine if two quantities are proportional, compare the ratio BA for several pairs of points to determine if there is a constant ratio. So you're just going to compare for a few of them, line them up, and see if you're getting a linear relationship. Let's look at example 2. Okay, I'll just zoom in a little bit more. Okay, so now here we have another table. So let's use the table to determine if there is a proportional linear relationship between a temperature in degrees Fahrenheit and a temperature in degrees Celsius. Explain your reasoning. Okay, so we have Celsius, which is what we use in Canada, and Fahrenheit, which is what they use in the United States. And we have plus 5, plus 5, plus 5, plus 5 each time. It's going up. And in Fahrenheit, it goes up plus 9, plus 9, plus 9, plus 9. So every time we increase 5 degrees Celsius, we're going to increase 9 degrees Fahrenheit. So it looks like our ratio, if we were to write it around constant rate of change, if we were to write it the other way around, where we write Fahrenheit on the top and Celsius on the bottom, we have 9 Fahrenheit for every 5 Celsius. Since the rate of change is constant, this is a linear relationship. To determine if the two scales are proportional, express the relationship between the degrees for several columns as a ratio. So let's see what we mean by that. We have degrees in Fahrenheit, degrees in Celsius. And we have 41 over 5 equals 8.2. 50 over 10 would be 5. And 59 over 15 would be about 3.9. Since the ratios are not the same, the relationship between degrees and Fahrenheit, degrees Celsius is not proportional. So here what we're saying is in real life, when we have 5 Celsius, it's going to be 41 degrees. What is the change between the two of them? Well, when I divide the top by the bottom, I get 8.2. But then when it's 50 Fahrenheit, it's 10 degrees Celsius. It's the difference here, the rate is 5. And over here is about 4, 3.9. So no, this is not by any means linear. So let's check. Graph the points on the coordinate plane, then connect them with a line. The points appear to fall in a straight line, and so the relationship is linear. the line connecting the points does not pass through the origin, so the relationship is not proportional. Okay, so you see here, it has to go through the origin. If it does not go through the origin, then we have to say it's not a proportional relationship. It is linear. We definitely get a straight line. Okay, it's a constant rate of change, but it's not proportional. Okay, you can see that 0 Celsius is not 0 Fahrenheit. It's 32 Fahrenheit. Okay, so now let's try it. Use the table to determine if there is a proportional linear relationship between mass of an object in kilograms and the weight of the object in pounds. Again, we're converting between metric and standard. Explain your reasoning. So here we have pounds. 20 pounds is 9 kilograms. 40 pounds is 18. 60 is 27. 80, and so on. So you can see here that every time I add 20 pounds at the bottom, it looks like I'm going to add 9 kilos. So 9 kilos is 20 pounds, and that's the constant rate of change. So my first statement is, it is a proportional linear relationship. Now I have to explain why. So my reasoning is because the ratio of mass to weight is a constant, 9 kilos to 20 pounds. So the rate of change is 9 kilos to 20 pounds, and that's why it's linear and it's proportional. Okay, if you feel confident with the guided practice, go ahead and take a look through it in order to know where you stand and how you're going to start next class. Make sure that you feel comfortable with the content, and we will tackle this as soon as you get to class. See you then, everyone.